Welcome back to another episode of Baseline Tech Talk. This is actually the third episode of season 2, and it's a follow-up to last week. So I see a lot of names on here that joined us last week. And last week we were talking about Auburn University and kind of gave everybody the high-level picture on what we were doing on site with the multiple water sources, with the cisterns, with the refills. And then today, Dan is going to go deeper into how we set up the programming so that you guys can learn how we this in software, and also just validates that we actually do this. We are not just talking about it, but we actually do it. And before we get started, I want to just remind everybody that if you're joining us for the first time, you can catch all the previous episodes on YouTube. And the Baseline YouTube name is called Baseline Web Training. So search on YouTube, Baseline Web Training. Every episode from last year and this season are there, as well as a lot of helpful how-to videos. And I believe you can go onto the channel and then just search for things. So if you're looking for something particular, you can't find an answer, try searching for it on the YouTube channel. And then just for some quick introductions, we have Dan Conger. He's going to lead us in today. He's the training manager. And we've got Idril Bowen, the RSM for the Southeast. We have Chris Wright, VP of Sales, and I'm Andy Humphrey. So with that, Dan, lead us off.
Awesome. Cool. So this is essentially a part 2 where it's a deeper dive into what we looked at Auburn University. So share my screen and we're going to talk about what we have over there. Over at Auburn University, right? It's in Auburn, Alabama. They've got grass, turf, and traditional irrigation for landscape. But then they also have some artificial turf with some big rotors. And that was, pardon me, they also have 4 wells that supply this site. And so here's a real basic look at their hydraulics on their site. So they've got 4 different wells spread out over the property. And Idril, I noticed last week that we've got well 1, 2, 3, and 5. So I'm assuming well 4 is another well and doesn't feed this system. Is that a good guess?
Did not produce, so it was taken out of the mix.
There we go. That makes sense too. Okay, great. We've also got a city water meter that's a makeup water. And then this all feeds this one cistern. And that cistern is what supplies the pump station. And then the pump station is what brings the water on to our main lines, right? So our main lines, some of them are landscape zones and some of them are the big rotor zones. We have different size main lines. We've got a 4-inch and a 12-inch main line. That was kind of the layout of what they have there on the site. But then the crux of the problem came, we've got a relatively small cistern, but a pump station that can pump the water like nobody's business. So we can drain that cistern in less than an hour at full tilt, right? Well, but it can take a while to recharge. So managing the flow, but also managing these other water supplies was the big challenge. And that really drove why they went after Baseline. And that was kind of how we solved the problem there. So another recap on the hardware that we used for that was this was really simple as far as hardware. We have a single base station 3200 and then a single substation to pick up wires because they were a little bit longer than their wire spec, but it could have been in a single base station 3200 because it's under 200 zones. They had flow sensors, master valves, some combined into a hydrometer. And then the only real other component that they needed was an event bicoder or event switch to take input from their pump station. So that's overview on hardware. Let's look at an overview on programming next. Overview on programming was the wells and the city water supply will feed that cistern when the cistern level drops based off of input from essentially the pump station, and that will trigger the event switch to start the different wells to feed that water supply, that feed that cistern. And then the cistern is going to feed that pump station, and that if the cistern ever runs dry, we have the ability to stop the pump station, and that ultimately the pump station is what feeds the main lines. Okay, so that's I kind of gave you last week's webinar in 5 minutes.
Yeah, and Dan, let me just add another way of looking at things. So in my brain, the way that I sort of visualize this internally is almost like we have two systems happening here. So with this slide that you have up where it shows the pump station and the cistern, that is essentially the water. So everything related to irrigation, all of the zones, all of the programming happens downstream of that pump station. So the 3200 is managing all of those zones, everything downstream as the irrigation system. At the same time, everything that's upstream from the cistern, it's also managing. And so the way that I think about it in my mind is I kind of split it into two parts where you've got your all the sources feeding the cistern, and then you have the irrigation system. And those two sort of programs, or those two setups, are running concurrently, because the irrigation is going to call for water at the very same time that the wells are feeding the cistern and coming on and off. And so those two systems are running simultaneously. So I just kind of wanted to add another way to think about it as you get into the program, so that we don't lose people into all these different configurations.
Awesome. Now, I guess if a person had the capacity, they could calculate out run times and flows, and then attempt to calculate run times on the wells. But man, the odds of ever running it dry or not maximizing that are just slim to none, right? The odds of that turning out well aren't good. So this is also, I don't want to say it's idiot proofing it, but it's definitely taking a lot of that human error out of the equation, which could be, the penalty could be quite steep. Okay, so on the programming, this is the gist of making this happen, right? Was multiple programs. So we've got 99 different programs available on the controller. They took, the 5 of the programs towards the end. They have program 90 is the city water, and then program 96, 7, 98, and 99 are the wells are the only zone, if you will, in that program. Those are the only things, and they're filling that up. And those programs will start or stop based on a condition, which we'll look at. So if we didn't have 99 programs, or if we had only 4 programs, this couldn't happen, right? We've got to have more than 4 programs. And I don't know about you all in your markets, but I've always have a challenge to people. It's like, what's a good reason to need 99 programs? Because sometimes people say, like, I don't need that. This is a great example of starting to need more than those programs. Okay, so we've got each well in a program, and then let's open up program 97. This is specifically for well 2. So one of the first things you notice is the start time isn't there. So in this case, it's going to run every day of the week. So we took away the start time. And time is a start condition. And in this case, we're not using time as a start condition. We're using an event switch. So if we look right below that, we see that RP00920. That is an event switch at the pump station. And that event switch, that condition, will start the program. So when the event switch gets some sort of a condition, it's going to take the condition from an outside switch that someone else manufactures and translate it into our baseline system, send it out over the 2-wire path, and tell the program it's time to start.
Yeah, and just to clarify, Dan, one thing that you said, that it will water every day because each one of the days of the week is enabled. Mm-hmm. It may not water every day. It has the ability to water every day. There's a difference.
Perfect clarification. Thank you. Yeah, that's because if it has to meet the day of the week condition, and it has to meet the event switch condition. So right. Essentially, we don't care what day it runs, but we do care what the tank level is like. And that's really all we care about right now. And so we're just turning it all over to the event switch.
Yep.
So the event switch will start it, but what's going to stop it? Well, in this case, the event switch is also going to stop it. Now, so what this is saying is when the event switch triggers, or the tank is empty enough, it's time to start. And when the event switch when it opens, right? And this depends on the switch itself. When it opens, we say the tank is full enough to stop. Well, Idril, when I first looked at the programming from this one, I saw that and I saw we were using the same switch to open and to close. And this kind of threw me for a minute because I had the vision of a traditional float switch, right? That was going to drop down and then that would tell it to start. And then as soon as that switch, that float switch changed, it was going to stop. Well, that's 6 inches. Then we'd be filling 6 inches. So where's this? This isn't getting the input from a float switch though, is it?
Oh, it's getting it from a level transducer that's in the cistern, and it's providing very accurate inches data. So when it gets a particular inch in the tank, it'll change the switch condition at that point.
But it's not. It's actually to clarify. It's not. It's not even just getting it directly from the transducer. It's getting it the transducers talking to the pump station, and the pump station so the pump station adds another layer of programmability. Is that accurate?
Right. Yeah. It has multiple set points. In this case, it's 4 different set points that it has available to it.
So you were able to leverage the intelligence of the pump station to use a one event bycoder to do a start and stop. That was kind of nice.
Right.
Now, you didn't have to. You could have done it a different way. You could have done it with 2 separate event bycoders for a top and a bottom if you didn't have the sophisticated pump station.
Right.
Okay. Nice.
And this is a function of utilizing the equipment that they had on site, right? Or had spec'd in association with the cistern and the pump station. So we had a customer or a participant ask the question, why would you not recharge tank based on level pressure in the tank? Lower level pressure, more wells come online. So again, we could have done it with pressure using our pressure technology, but in this case, we were conforming to what they had spec in terms of the cistern and the pump station, correct?
And also what was available
Right.
at the time that this was, yeah.
Exactly. Yeah. We didn't have that available when this system was drawn up initially, but now if it was today, we use our pressure transducer with a lake level transducer and monitor directly and take the impact and the input directly in our system.
Yep. So I think my point is that we have the ability to, not to coin my favorite phrase, think outside of the start time, right? And utilize other technologies to help us perform functions associated with the system.
Beautiful. So in the runtime here, we've got an hour runtime, and if it hits that upper limit, if you will, if it fills up before it hits the 60 minutes, it'll stop. So you wanted to have enough time in there to fill up the tank, but make sure that you could achieve something with it. So now we also have 4 wells all dumping in at the same time. So we do have to have a runtime in there, but the sensor will be, or the event switch will be the one that can interrupt it. So we do have a start time in there. The other thing that's important on the program is this obey global conditions, right? So the obey global conditions is opting it out mainly about rain sensor input. So if we had a rain switch on this system that would shut down all zones during a rain event, well, this is a zone, okay, right? But one pump start relay is the only zone in this program. We don't want it to stop. We want it to keep running. So we have opted it out of that obey global conditions. Traditionally, we think about that in lighting and other non-irrigation things, but this is not actually applying water to the field. It's part of the water movement within the system.
Yeah, and Dan, I'm just thinking about it. This would be you'd always want to uncheck that even if there is no rain sensor. Because if the user were to use what we call global commands, i.e. shut down all controllers, let's say within their account globally, this would ignore that because that's also a global command. Just turn everything off across all controllers.
I like that. Yeah, good call. The other one that's in here is this include.
Well, that's the point. That's actually a situation we had out there where they turn things off and they turn the dial to off And I had to coach him into, if you want to turn off irrigation, please use the rain shutdown so we can still continue to fill the cistern. So it was just a little training on their part. They had to learn, don't turn the controller off, do a rain stop, and then we can still continue to maintain tank level.
Mhm.
I could see a rain event as a great time to catch up on filling up that cistern, right? Because after the rain event, let's have that cistern topped off and ready to go for irrigation whenever the irrigation is going to come back up again. Especially if you're in a market that gets summer rain. I don't get summer rain here in the West Coast.
Are they capturing any of that rainwater into that cistern? Hydro?
No, not
okay
at all.
There you go. There'd be some free money, free water on that one. So that include with total controller concurrency is about hydraulic capacity of the system. So if I had zones that are going to create a demand on my 4-inch or 12-inch mainline, I want to manage how many zones can be on there. Well, if we looked at the lighting example, if I had a lighting program, well, that doesn't take anything away from the hydraulics. Well, this program doesn't take anything away from the hydraulics. Actually, it's contributing to the water supply. So this doesn't count in how many zones we can run at a time, because it's only about adding water, not taking water away from our system. So that was the other thing that I thought was worth applying in here.
What about schedule priority, Dan?
This one,
how does that factor in? It may or may not in this case, but how would it?
Yeah, in this case, it actually doesn't factor in, because all of these are supplying water in. If they were using the city water supply as a makeup, they might use a priority there. Right now, they're using it. I believe they're only using it as a manual, like emergency over. If we wanted to have the secondary water supply as a backup, we could probably use priority for that. But in this case, it doesn't. There is no application on that.
Okay.
So I think that gets us through the programming portion of it. Oh, now we need to look at the main lines, right? So they have the two different main lines, right? So we've got a 4-inch main line for the landscape zones with the lower limit, and then the big rotors are on the 12-inch. Okay. So for that, we go to the flow setup tab, and then specifically main lines. So the first thing we notice is that there's already two main lines set up, and we can see there's a whole lot of zones on mainline 1, that 4-inch main line, and then fewer zones on the 12-inch. Well, you need to know the layout of your system. You need to understand that which zones are attached to which pipe. It's basics on knowing your system. And if you don't, you need to map that out. Well, on zone 12, those are the big rotors that are going to feed the artificial turf, for the high demand, high flow, high pressure. Those are assigned to a different main line. And that can be done inside this mainline setup. So under this flow setup for the 4-inch main line, we've got the design flow set to 200 GPM. That's the main thing we're setting up on here. We have the option of some advanced flow variants specific for this main line, or mainline zone delays specific to this main line. And then if we needed to move zones between, if we had zones that belong on the 12-inch and they're not actually on the 4-inch, we could open zone assignment and set that up as well. And then on the 12-inch, we have the exact same thing, but here the design flow limit is much higher. So we have a lot more capacity on this one. So the thing that I noticed is managed by flow is not checked. And I had a little bit of information on why you thought they weren't using managed by flow.
Well, unfortunately, we were experiencing about a 15-gallon a minute leak, and we're unable to learn flow because it was different. When the pumps were running, it was a different amount of a leak. At rest, it was another number. So they just recently found that leak and repaired it. So going forward this spring, they're going to be able to actually learn the flows on individual zones with a good, accurate number that won't fault out.
Okay. So that was a 15 GPM leak that they knew about, though. Or that they knew.
Yeah. our controller was showing the leak. It was monitoring and it was reporting it, but they couldn't locate it. And unfortunately, it was underneath a sidewalk and near a building and on the 12-inch main line too. So quite a job to find. And but it took them a couple of months to actually find it. That's how bad it was. But they've now since repaired it.
So actually, let's talk about this for a second, because I think, learned flow is it's important to make this work, right? So one of the things to make managed by flow work, well, actually, I need to stop the truck. And managed by flow is the ability of the controller to puzzle piece multiple flows together. So if we have 1200 GPM to work with, it can find, two 600 GPM zones, or any combination of zones up to 1200 GPM, or whatever the limit is that you put in. And we'll puzzle piece those together to maximize the hydraulics and to maximize your runtime, so your water window. So, but it's doing that with the learned flow that you're talking about. So what would happen if they learned flow and it says it's only 100 GPM when in fact it's 115 GPM? But that managed by flow wouldn't be accurate, correct?
Right. You're gonna get constant fault outs. You're gonna get messages and errors that it won't make a lot of sense, but you'll eventually we already figured out that it wasn't reading properly and it was giving us inaccurate numbers.
Right.
And from those ranges, anywhere from the 1,1300 gallons a minute, it's running a percentage of that one number and that many number of gallons. And then if it's a lower amount of output, it's a different amount of a leak. So the leak the number moved as you started running stuff. So it caused all sorts of crazy numbers.
Yeah. Okay, good.
And we've got a quick question about that previous slide as it relates to assigning zones to main lines.
Oh, okay. Yes.
And the question is, what happens if you forget to assign a zone to a main line? And I'm going to take a guess, because I don't factually know the answer to this. I think if you forget to assign it, the zone runs all by itself. But if anybody else, Chris or Idril, know what happens if you forget to assign, chime in. But I think that's what happens.
I believe you're right, Andy. I believe it'll run by itself and won't run in any concurrency.
Because the controller doesn't know. You haven't told it where it's located, which main line is it sourcing from. So it just has to run all by itself.
Nice. And I think, and this is why sometimes, it isn't always pretty. I've got zones, there's 102 through 124, all sequential. It's rarely pretty like that, right? Especially on a site that's puzzle pieces and a campus was a great example that they keep adding on layers and connecting things. New parts of the project might be a little more sequential, but that's not always the case. Any comments or thoughts on that from the?
Yeah, we've had a couple of questions come in. If you have any other questions, please feel free to put them into the Q&A or the chat, and we'll address them. We've got a few minutes,
yeah,
so
Dan,
why don't let's summarize everything that we talked about, kind of bring it together, because we've talked about different concepts that have kind of fragmented it mentally. Let's bring it all together as a wrap up to the 2-session presentation as to what was accomplished.
Okay. So in this case, they've got multiple wells and multiple water supplies. They're dumping into a single cistern, and they're using that controller on part 1 to manage those water sources to keep that cistern full, not let it empty, and to turn on those water supplies at the right time. Then the other thing that's
keep in mind, if you remember Dan's diagram, there were no main lines on that part of it. So those wells feeding the cistern was simply on demand, just turning the wells on and off as needed to keep the cistern full. There's no main lines, there's no water sources. It's not fancy. It's just on programs coming on and off on demand, keeping the cistern full.
Right. So the cistern is managed by the cistern level and water our single water source is managed by the controller. The other thing the controller is doing is then using that water supply to run through the pump station and feed main lines of various sizes, and to have those main lines of various sizes have particular zones with them, and then to manage the flow on those individual main lines to do a couple of things, right? Is to keep that pump running at it where it belongs, at its sweet spot, but also to compress that watering time and compress that water window down as small as possible, all the while not running out of water and not having the tank overflow, right? Those are two parts of that one.
Yeah. Yep. So this is a classic example of how we're able to manage secondary water sources efficiently to provide the performance for the irrigation system that is required, which is really quite complex, right? So speaks a lot to the ability of the baseline technology to achieve that and to manage it efficiently and without a lot of human input to try to manage it and create those errors. Very cool.
I got a question for Idril if we got time for it. One, when you first looked at this project, did you look at it and figure, how am I going to solve this problem? Or was it like, oh, I got this. All we got to do is do this, this, and this? Because the reason I ask that is sometimes there's 6 different ways to solve a problem, and you need to kind of piece some information out.
It was, it wasn't that easy because the plan kept changing. What the university wanted to do, how they wanted to do it. It went from booster pump cistern. I mean, it's shifted around several times until they finally settled on the end solution. At that point, then it did kind of fall into place. It all made sense, and I knew we'd had the ability to monitor through their pump system. It's the Watertronic system. They've actually done this before on another project with the same designer, so it wasn't totally foreign to what we needed to do. So nice. It worked out nice. It worked out nicely.
Yep. And hey, let me add one thing here. Now that we've got everyone's attention near the end, we have a quick call to action. This would be for the ears of distribution. So if you're on this call today and you are working in distribution and you haven't already been invited to our Distributor Mastermind series, which the first one in the series is this Thursday, I'm going to put a link here in the chat. And again, this is just for distribution personnel. If you would like to join us as a registration link, and we would greatly having you in this series. This is going to be a little bit, as Chris likes to say, instead of joining us in the booth at IA, we are trying to get our key distributors together on a conference call starting up this week. So I'm going to put it right here in the chat because we know we've sent a lot of emails. Not everyone's registered. Not everyone's had the emails. And so we know if you're on this call with us today, you are a key distributor for us, and we'd love to have you join.
Absolutely. Beautiful. Very good. All right. So what's on store for next week, Dan?
Runoff. I'm going to talk about preventing runoff, because my water conservation nerd hat on is every drop of water that runs off your site is wasted. So there's several different ways that we can manage that and to minimize runoff on your site. So that's what we're going to break into.
Very cool. Good topic.
Cool.
For sure. All right, everybody. We appreciate you joining us today. Any famous last words, Andy?
No, if you're a distributor, join us Thursday. You got to be there to know what's coming up in 2021. So it's going to be a big year, and we need all of the help from our key distribution personnel like you. So please join us.
Perfect. All right. Very good, everybody. Go out and be productive. Be safe, and we will see you next week for another edition of Baseline Tech Talk Tuesday.
See you then.